Hi dear students, how are you? I hope you're fine. Today we're going to talk about transformations on the coordinate plane. Remember, we have taken this last year. When I talk about transformation, this means that they are just movements on geometric figures, just as translations, rotations, and reflection. So when I talk about translation, this means that I'm going to slide or here to slide is a slide where a figure is moved from one place to another place in a vertical or horizontal movement. So this is what? This is a translation. What about the rotation? The rotation, it means that the object is turned around a point, a fixed point. What about a reflection? A reflection means that you're going to flip the figure over a line, and then the transformed figure is the mirror image of the original. So I have here I have the original figure and the reflection form have a symmetric figure. Okay guys, remember this together. Okay, so when I talk about this one, and I ask you what kind of transformation that we got here. So this is what it rotates, turned. So this is what this is a rotation. Yes, this is a rotation. And if I ask you here, guys, remember, tell whether each geometric transformation is translation or reflection or rotation. What about this one? It rotates, so this is a rotation. What about this one? It's like a mirror here, so this is a reflection. And this one is slide. It moved here like a slide. So this is what? Slide translation. And this one is, it's like reflection. It's like a mirror. Okay. I have here, which of the following has exactly one line of symmetry? Guys, the isosceles triangle only that has here the just one line of symmetry. So isosceles here, this one, because it can be divided into two perfect here, two equal figures. So let's have here another kind of things. We're going to talk about it. The quadrilaterals. Remember, quadrilateral is a closed figure, consists of four segments that they intersect at exactly the end points. So like this. Okay, so the quadrilateral, guys, this is very important information. Now the quadrilateral, the sum of measure of angles of a quadrilateral is 360. We have some types of quadrilaterals. As you see, this is a quadrilateral with no pair of parallel lines. This kind it's a parallelogram. Each two opposite sides are parallel to each other. Trapezoid, just one pair of sides that are of opposite side here that are parallel. Rectangle, all the sides are each two opposite sides are parallel. Each two opposite sides are equal in length, and I got here all perpendicular, all here perpendicular. So I got here 90 degree. Okay, we got here 90 degree, 90 degree, 90 degree, 90 degree. It's important to here study well the features or the characters of the quadrilaterals. Square, each I have here all sides are congruent. Right angles also, I have got here right angles, each two opposite sides parallel. Rhombus here parallelogram, which with what each two opposite sides are here parallel to each other. All here sides are congruent. So I have here an example. He asks you here a quadrilateral with 35, 79, 118. What's the length? What's the measure angle of the fourth angle? The measure of the fourth angle, I will here add all of them and then subtract them from 360, which is the total measure of angles of a quadrilateral. So I've got here the remainder 128. Here I have some practice. Find the value of x. Okay guys, find the value of x here. You got here 90 degree. This sign is 90 degree. 90 and 90, 180 plus 130. So you got here 3 and 8, 11, 2 and 1, 3. So 360 minus 310, you got here 50. So x will be 50. What about this one? I have 140 plus 140, so you got 280. So I need to know the remainder, 360 minus 180. 0 minus 0, 0, 6 minus 8, 16 minus 8 gives me 8. 2 minus 1 gives me here 1. So I got here 180. But remember, this is not 180. 140 plus 140, 280. So this is just here 80. So this is just 80. So we have here again, please, 140 plus 140, guys, 280. Okay, we just we have here 360. I wrote this 360 minus 280. 280. So you got here now what you got here, the 80. So if you got here 80 divided what? I have x and x, two x's. Okay, so I have here 80 divided 2 to get here x and x. So equals 40. So here x 40 and here the other x is 40. Okay, easy, but do the calculations right. You got here 90, this is 90. You got here 135 and here x and x plus 5. Okay, so it's easy to do it. Okay guys, let's solve this here step by step. I have here 135 and 90 degree. So 135 plus 90 degree. So 5 plus 0, 5, 3 plus 9, 12, 1 and 1, 2. So we got here 225. The total here measure of angles 360 minus 225. 0 minus 5, 10 minus 5, 5. Here I have 5 minus 2, 3. 3 minus 2, 1. The remainder 135. So I will write 135. Okay. It's equal to what? Equal to x plus 5, this angle, and the other angle x. So 135 equal x plus 5 and what? Plus x, the remaining angles. So x plus x gives me 2x. X plus x, 2x, and I have plus 5 here and 135. The plus 5 will go to the other side by negative sign. 135 minus 5 equal what? 2x. So it will be 130 equal 2x. X alone divided 2, x will be 65. So x here is 65. The other one, it will be what? X is 65. And the other one will be what, guys? What do you think? It's 65 plus 5, so it will be 70. 70, 65, 135, and 90. Now it's very easy. Here list every name that can be used to describe the quadrilateral. Indicate the name that best describe the quadrilateral. Okay, number 4, what do you think here? Number 4, a quadrilateral. Number 5, it's a quadrilateral. This parallelogram, it can be rhombus, rectangle, or square. Okay, what about here? Number 6, it's what? It can be quadrilateral, parallelogram. Okay, quadrilateral or parallelogram. I have here for number 7, quadrilateral, parallelogram, or rhombus. I have here number 8, trapezoid, quadrilateral. Okay, determine which statement is false. A rhombus is a parallelogram. This is true. A rectangle is a parallelogram. True. A square is a rectangle. That's true. A trapezoid is a parallelogram. What do you think? Is a trapezoid a parallelogram? No, that's false. Okay, guys, by this we have finished all the week's lessons. I hope you understood everything. If you have any question, please send me on the SCL. See you. Bye bye.